Alright, geometry, this is Friday's warm-up, the multi-step proofs warm-up. The first two questions are not actually proofs, but we're going to go through them anyways. The first thing is proving triangle ABC is congruent to what triangle, and how are they congruent? What I already did is I took this triangle DFE here and I kind of flipped it around to reorient it to look like triangle ABC. Notice A and F now line up with their congruent angles, side BC congruent to side DE, and angle C congruent to angle E. So what that makes me think is that I've got an angle side situation, and it looks like triangle ABC would be congruent to triangle FDE, and that would be my angle side. The next problem is overlapping triangles, and what I already did was redraw these two triangles. We've got triangle RWS and triangle RST. See those two triangles that overlap. Now what I want to prove is triangle WRS is congruent to which triangle? Well, WRS looks like it would be congruent to triangle TSR. But if we look at what we have, we've got sides congruent, RS being congruent to itself, ST congruent to RW, and angle W congruent to angle T. This would create an SSA situation. Now we learned in class that SSA is a congruency shortcut that actually does not work. So this is not congruent to triangle WRS would not be congruent to triangle TSR, even though they line up and the congruencies match up. We know that SSA does not work for this situation. It does not prove triangles are congruent. So these are not congruent. Alright, our third one is a proof. I'm going to go ahead and mark my givens to start. AB parallel to DE, and C is the midpoint of AE. Now I want to prove triangle ACB is congruent to some triangle. I'm guessing this triangle here, but we need to make sure that we label it correctly. So first we have parallel lines, AB parallel to DE as a given, and something happens in a box, and we're given that angle A is congruent to angle E. Well, if I think about these parallel lines and this transversal that comes through the middle here, angle A and angle E sure look like alternate interior angles. And we learned from our conjecture sheet that if there are parallel lines, then the alternate interior angles are congruent. Therefore, angle A would be congruent to angle E. Alright, so we've got one angle so far. C being the midpoint of AE, we know that makes congruent segments AC and CE, so that's going to come out of our box, that AC is congruent to CE. And then we need a reason for that. Well, again, we know that if a point is a midpoint, then it splits a segment into two congruent segments. So I'm going to write that shorthand. If midpoint, then split segment into two congruent segments. Therefore, AC would be congruent to CE. So now I have an angle and a side. Now lastly, we've got a blank thing here going into a blank box and giving us that ACB, this angle here, is congruent to angle ECD. Well, we can see that those are vertical angles, so this must be a diagram step. And we know from the diagram that if two angles are vertical, then they are congruent. Sorry, I can't fit that in the box. Therefore, angle ACB is congruent to angle ECD. And what I can see now is an ASA situation. Now I just need to make sure that I label my triangles in the right order. So if we go A to C to B, that starts with an orange tick mark to the purple tick mark to the non-tick marked vertex. So I should start orange to purple to non, so E to C to D. It's triangle ECD, and this is by an ASA situation, ASA triangle congruency. And that is my proof.